Welcome back to my channel where we start a lot of projects and never actually finish any. I'm fortunate enough to have picked up a DGX Spark. Local models are all the rage. And I wanted to show you folks some tips, tricks, and kind of, how I'm already observing an ROI within 7 days of having purchased the DGX Spark. This is the GB10 Superchip. This is a Grafana dashboard powered by Prometheus. We are extrapolating metrics from the DGX Spark itself as well as vLLM. vLLM is not running inside of Docker. I will get it in there. But we are going to be hosting the Qwen 3.627B FP4 from NVIDIA. I have found this to be the highest open source quality with the largest context window for open source agentic coding harnesses. Now, this is subject to change. This video may be obsolete by the time I upload it. However, at the present time, this is my go-to daily driver. We'll get into some details. If you're interested in my configurations for the deployment, I am running 6 concurrent. I think I can bump it to 8. I'm running a 131K context window. There's a reason for that. You certainly want to be over 100K, especially if you're using GitHub Copilot. You want to be under the 150K because that's when Qwen starts to take context history a little seriously and it starts to go off on its own thing. It's not necessarily a hallucination. It's just not aligned with what you've asked it to do. Yes, we have speculative decoding on. We're doing 3 token speculative decoding. This basically doubles your TPS, which is really important. This model on here at these configurations, massive context window, 16K batch tokens, you could probably bump this to 32 with pre-chunk enabled, prefill enabled, you can do about 7 TPS. Now hold on, you're gonna go, Ryan, 7 TPS, that's terrible. If you can do 6 to 8 concurrent sessions and you know how to use tools like GitHub Copilot, then when you're launching sub-agents, you could do 90 to 100 TPS easy. So I'm actually going to show you that right now. This is a little bat file. I'm going to probably install this in my machine more permanently. You can see I'm just pointing directly to the Spark on my network, and I'm just booting the device with the model that's loaded at the base network. And so here I am. I'm going to run it. We're going to boot into GitHub Copilot. I do have lots of things going on right now. This is in experimental mode, which is great because there's a lot of awesome features in experimental mode that I hope that they GA. But I also now have an active session, so I can actually code remotely. I can get away from my computer, I can open the GitHub app on my phone, and I can continue this session. I can be out in the world and continue to code using my DGX Spark in my house. You can see we have Qwen 3.6 as a selected model, AIC is 0, and so we're in autopilot mode, and I am going to provide it an interesting prompt. Watch and learn, and then we'll go back to the dashboard and we'll watch the dashboard. All right, so what I'd like you to do is I'd like you to launch 6 subagents, and I want you to go to 6 AI websites, just 6 random AI websites that have information about the Qwen 3.627B FP4 model from NVIDIA. Maybe Huggy Face is one of them. And I want you to start just pulling down information and then present to me in a single presentation everything that you found. Go. So we're going to fire off that prompt, and we're going to be watching this while we also talk about a few other things that I've noticed. So the DGX Spark, it does not have the same memory bandwidth as a 5090, right? So the 5090 is going to have HBM DDR7. The DGX Spark has DDR5. And so if you're looking for high token throughput, the DGX Spark is not the tool, but the GB10 chip is extraordinarily good at concurrency. And so this is where if you're methodical and you know how to plan your workloads, or let's say you have lots of simultaneous workloads, the DGX Spark is going to be extremely good for simultaneous workloads. I know that it's possible on a 5090 to also do the same thing, but with all of this unified memory on the DGX Spark, you're going to get a lot more bang for your buck. So for example, when I launch these sessions, I give it a massive memory cache. I give it probably too much. I could probably load a 35 billion parameter model in memory concurrently, but I want to give it as much freedom in its KV cache and its prefill as possible. So that way my TPS is as low as possible for time to first token. I said TPS, time to first token, TTFT. If you can keep your TTFT low, when you're thinking about concurrent workloads and simultaneous agents, that's also when you can launch more concurrent workloads. And that's when you're going to see that extremely high TPS. So if we can keep this refreshing here, we're going to start to observe as it's launching these sub-agents, a relatively high TPS starting to come in. So I'm going to refresh this to see if it's coming in here. And let's just go. I have 12 hours. We're down at 15 minutes. Look at that. We're already at 24 TPS. So on a single instance, we're going to observe about 7 TPS on this model, right? But now that I'm launching concurrent agents to solve multiple problems, you can see here we have concurrency of 2 at a peak there. It's going to continue to draw down and accomplish its task with more throughput. Now, when the session first started, yes, we had a really high time to first token, and that's because it was the first session. We got a lot of prefix that we got to establish there, but once that prefix is established, that's now when you're going to see it drop down. Your time to first token is going to drop down. The sub agents, their context windows, while large, the initial prompt is much smaller, and that's also something you want to be thinking about too with your sub agents and your tooling. Is what's the size of your prompt? The sub-agents are going to launch with a much smaller prompt, which makes them faster. So if you can think of ways to distribute your workload into sub-agents, you're going to see an enormous amount of work get done concurrently. And that's where the GB10 Superchip really shines. And that's why I got this, is because I'm proficient with executing my work across sub-agents. The work that I do, where I may be working on a single repository or multiple repositories, sub-agents, with the new experimental mode, there is a scheduled prompt. You can schedule a prompt in GitHub Copilot, which is absolutely amazing. I love doing that one. Running a long job, then schedule a prompt to run 30 minutes later to check on the status of the job, and then send me a notification on the status of the job. It's amazing, right? When you start to think of your coding harness as more of a utility rather than just a chatbot to interface with your code and to write code, you can get a lot more. Now, I apologize, I'm not getting the 90 TPS that I described earlier. GitHub Copilot chose to only launch 2 agents, or I'm sorry, 3. It looks like it launched 2 sub agents, and then it was the third agent that was doing the what do you call it? Agentic harness, right? So that's that. I mean, this is an extremely capable device, and you can see already just in the last 15 minutes, if I were to have run this equivalent query on, let's say, an Opus, I would already have consumed $2.33, right? Whereas if I was using a Haiku, maybe around $47. There it is. You can see we're now at 4 concurrent API calls. So right now, the GB10 is processing 4, now 3, concurrent LLM requests. So that chip is working hard. Now, this chip is also getting extremely hot. If no one's told you the GB10 gets really hot, don't put something like a 3D print on top of your GB10, because your 3D print will melt. There it is. You can see we're going up to 36 TPS as it's launching more, and it just launched another sub-agent. So maybe we'll keep this video going just for another minute or two. But this is what you can expect. I really like that Grafana gives you an out of the box dashboard. Oh, there it is, 44 TPS. You can go into edit, and then you can obviously copy as code this Grafana dashboard, and then just give it to your model and say, make this dashboard better, which is what I did. And so that's how I've ended up with this dashboard for this level of visibility. And this type of dashboard also helps you dramatically optimize your model's throughput. So what maybe most people don't tell you about the DGX Spark is you do have to become proficient in pretty much all the parameters that are available for tools like vLLM or Ollama. Don't use Ollama on a Spark. That's a waste of your time. But you have to be proficient with the tool, because you do need to tune the model to your specific workload. So there's lots more that can be tuned out of this. I'm sure somebody's looking at that saying, you could totally crank that up to 8. You could totally crank that up to 32. But I'm really liking where this is at, and maybe tonight I'll run the experiment. But it is possible to just completely overshoot, and then you just start bottlenecking on the chip. You start bottlenecking on memory bandwidth, whatever it is, right? So you can see here we are, 47 TPS. It's now finished its report. All 8 research subagents are now running in parallel, it says. And so I guess it's not finished its report, but there it is. So while this model is not the highest performing on the GB10, if you become proficient in subagents and executing and modularizing your tasks, or understanding how to request the AI to modularize your tasks, you can see you can get 42 TPS, 36 TPS. In some cases, if I extend to the last 24 hours, come on, there it goes. You can see over here, down here is my 11 TPS. Up here, I was at 90 TPS, right? And I'm looking to see if I can squeeze more out of this. So I wanted to make this video because I heard people were interested in the DGX Spark that I got. and maybe there's going to be more to come. I have some really, really cool workloads running on it right now that hopefully I can demonstrate, hey, if you get this thing can just be running all day, every day, behind the scenes, nonstop, doing work for you. And it's now your home workload. Yeah, thanks for watching.